Hello everyone. Today we will start the class with multiple choice questions from the chapter Sets, Relations and Functions. So the first question you can see is, if the set A has n elements, then the total number of subsets of A is. So clearly, total you have number of elements in the set A as n. So that means you have n elements. When you want to make subset from these n elements, you can select nothing, or you can select 1, or you can select 2, or in that way you can select all the n elements. And in binomial theorem, there is a formula for this. It is 2 power n. That means total 2 power n subsets can be formed. Option will be C. The second question is similar to the first one. The number of non-empty subsets of the set 1, 2, 3, 4. So here in the set A, total 4 elements are there. So when you make subsets from these 4 elements, you can select nothing, or you can select 1, or you can select 2, or you can select 3, or you can select 4. That means total 2 power 4. That is 16 subsets you can form. But the word non-empty, the subset should not be empty. When you are selecting from 4 nothing, this will be empty subset because you are selecting nothing. But they don't want this empty subset. So from 16 subsets, you have to subtract 4C0. 4C0 means one subset which is empty, that you have to subtract. That means 15 subsets, that too non-empty subsets, can be formed. And so you will go for the option 50. The third question is also similar to the previous one. If a set A has 4 elements, so number of elements in set A is 4. Then the total number of proper subsets of A. Just now I told you, from total 4 elements, if you want, don't take anything, or take only 1 and form subset. From 4 you select any 2, from 4 you select any 3, or from 4 you select any 4, all the 4 I mean. So total 2 power 4, that is 16 subsets are formed. But they are asking for proper subset. What is meant by proper subset? A is proper subset of B. That means you should not take A as B. Don't take A equal to B. This is proper subset. I told you the definition of proper subset. A will be just subset of B, but A will not be equal to B. So when A will be equal to B, from 4 elements, if you take all the 4, here A will be equal to B. So don't take all the 4. From 16, you subtract 4C4. That is, from 16, you subtract one subset, and that will be 15 subsets. So again, the answer for the third question is also 15. Next is fourth question. F of x is given as a minus x power n whole power 1 by n. Then you have to find f of x. That means in f, you have to substitute f of x. And f of x is a minus x power n whole power 1 by n. So, in the function f, in place of x, you will be writing this whole thing. So, when you write, first you write a minus, in place of x, you will be writing a minus x power n whole power n. This is x. And then this x will have power n. And then whole power 1 by n. Just in place of x, I have substituted this. In place of x, I have substituted this. That's the only thing I did. But I will simplify. When I take a minus, first thing is I'll write separately this part. I have a minus x power n whole power 1 by n and then whole power n. So this n and this n cancels and I have just a minus x power n. So a minus x power n. So I have taken entire this part and I have simplified. Now left is whole power 1 by n. Now here I can remove the brackets a minus a plus x power n whole power 1 by n. Cancel a. So x power n whole power 1 by n. N and n cancels, x power 1 or x will be the answer. The next question is fifth question. If the set A has p elements, number of elements in set A is p. Then the set B has q elements. Number of elements in the set B is q. Then the number of elements in the set A cross B. The shortcut formula is you have to take number of elements in set A and multiply to number of elements in the set B. That is, you will multiply P and Q. So PQ will be your answer. Question number 6. Number of elements in set A is 3. Number of elements in set B is 6. These two are given. Then it is very important that A is subset of B. That means if you draw Venn diagram, it is easy to understand. Universal set. This is the set B. A is completely the subset of B inside B. Then the number of elements in A union B you have to find. So when you shade A and when you shade B also with the same design, A union B, you can see that it is nothing but the set B only. So A union B means the set B itself. And in set B, 6 elements are there. So the answer will be 6. Next, we can go to question number 7. Number of elements in set A is 3. Number of elements in set B is 6. And again, A is subset of B. So again, if I draw the Venn diagram, universal set, and I will take set B, set A inside the set E, because A is subset of B. Now you have to find number of elements in the set A intersection B. So A intersection B means the region which is present both in A circle and B circle. This is the region present in both A circle and B circle. That means it is nothing but A. So A intersection B is same as A. And the number of elements in set A is 3. So answer would be 3. The next question is question number 8. The domain of the function y equal to f of x, that is 1 by log of 1 minus x base 10 plus square root of x plus 2. So first of all, you take the first part of the function. Log of 1 minus x base 10 is in the denominator. So you can easily say that this number 1 minus x should be greater than 0. And one more thing you can say, 1 minus x should not be equal to 1. It has to be greater than 0, but it should not be 1. Because if at all this is 1, then it will become log of 1 is 0 in the denominator. If 0 will be there in the denominator, the function will become undefined. That's why 1 minus x should be positive, because for log, the number should be positive, and the number should not be equal to 1, otherwise the log will become 0. So from this I can say x will be less than 1 and x is not equal to 0 when I solve these two. This is very important for us, so we will keep this, we will highlight this. Coming to the next part, square root of x plus 2. For square root, the number x plus 2 or whatever is inside the square root, it has to be greater than or equal to 0. That means x has to be greater than or equal to minus 2. This is another important thing which we have to keep. Now on the number line, the important numbers you will take is minus 2. Of course, this is the number line. I will write like this. Then one more number you can see is 0 and the other number you can see is 1 being discussed. So x is equal to minus 2. You put square brackets. X is greater than minus 2. Going this way. X is not equal to 0. And x is less than 1. Just less than. 1 is not included. It's given that x should be less than 1. That means you can break the interval at 0. You can take minus 2 to 1, but you should not take in the middle 0. And that is option C. Take the interval minus 2 to 1. But we are not taking 1. Remember, we are not taking 1 because x is less than 1. So open brackets here, minus 2 to 1. In the option, there is slight printing mistake. You correct it. Like this. So minus 2 to 1, don't take 1 and don't take 0 also. But option C will be the correct one. Coming to the next one, domain of the function log of log x. First of all, if you see the outer log, this one, absolute value of log x should be greater than 0. Isn't it? Because for log, the number or whatever it is, it should be greater than 0. Of course, It is a modulus function, absolute value function. So it will be greater than 0. But you have to see that log x also is there. Inside this, log x is also there. That means this x has to be greater than 0. Because you are talking about this log x also. For log, x has to be greater than 0. But one more thing I will come to know that, of course, greater than 0 is okay, but it should not be equal to 1. Because if x is equal to 1, what will happen? Log 1 will become 0. But we are not supposed to take 0. We have to take greater than 0. We should not take equal to 0. That's why x should not be 1. I hope it is clear. X should not be 1, because if x is 1, log 1 you will get 0, whereas it has to be greater than 0. So don't take x as 1. Take x greater than 0. So when you take greater than 0, means you will take 0 to 1, because you are not taking 1. And after 1, up to infinity. So in between 0 and infinity, 1 is not taken. So the option will be option C. Coming to the next question, the domain of definition of the function cube root of 2x plus 1 by x square minus 10x minus 11. So because it is cube root, you can have plus or minus inside the cube root. For square root, you should not have, but for cube root, you can have. But no problem about the cube root. But if you see the inside fraction, denominator should not be 0. Because if denominator is 0, the fraction will become undefined. So you will take x square minus 10x minus 11 not equal to 0. Now you have to factorize this. X minus 11 times, the other factor will be x plus 1. It should not be equal to 0. That means x should not be equal to 11. X should not be equal to minus 1. So we can go to option D. Let us take the next question. Coming to the next question, that is question number 11. If f of x equal to x cube plus sine x, then f of x is what kind of function? Even function or odd function, we will see. I will find f of minus x. That means because I know what is f of x. I will put x as minus x, then cube it, plus I will put sine of x as minus x. So when I take minus x cube, I will get minus x cube. And sine of minus x is minus sine x. Now, if you take minus common, x cube plus sine x is left. Whereas x cube plus sine x is nothing but the function f of x. So I can write f of x. So that means f of minus x is equal to minus f of x. This happens only for odd functions. That's why you can take it as odd function. Question number 12. The inverse of the function y equal to 10 power x minus 10 power minus x by 10 power x plus 10 power minus x plus 1. So if you want to find inverse, instead of y equal to, you must have x equal to. So for that, what I will do, some necessary arrangements. 10 power x minus 1 by 10 power x. Because the power is negative, I took it to the denominator to make the power positive. Similarly, in denominator, 10 power x plus 10 power minus x will be 1 by 10 power x. Now, there are too many numerators, too many denominators to make it into a single one, easier fraction. I have to remove the denominator. To remove the denominator, I will multiply 10 power x up and 10 power x down. Because my main aim is to remove the denominator. There are many numerators, many denominators. So when I multiply, when I distribute, when I multiply, I will get y equal to 10 power 2x, because I'm multiplying 10 power x, 10 power x, minus, when I multiply these two, 10 power x will cancel, I have minus 1. Denominator also, when I multiply 10 power x and 10 power x, 10 power 2x, then 1 I will multiply with 10 power x. 1 by 10 power x, I will multiply with 10 power x, 10 power x will cancel, I will have plus 1. Of course, this last plus 1 will be same. We are nothing dealing with plus 1. Like we are not dealing with it. So now I can bring y minus 1 to this side and 10 power 2x minus 1 by 10 power 2x plus 1. Actually, here denominator I can take 1. Now I will apply componendo and dividendo rule. What is componendo dividendo rule? You have to take both the sides, because there are fractions on both the sides. You have to take numerator plus denominator by numerator minus denominator. See how I'll do. Numerator plus denominator by numerator minus denominator. Similarly, this side also, numerator plus denominator by numerator minus denominator, means it will become minus 10 power 2x and minus 1. So what will happen is minus 1 and 1 will cancel. You will have y by y minus 2 equal to, here minus 1 and 1 will cancel. You will have 2 times 10 power 2x by, here 10 power 2x and 2 power cancel, minus 2 you will have. So 2 and 2 can cancel. That means I will erase on the top, because now I don't have place to write. I will keep the last step. I will erase just the top one, so that you can refer to the last step and know what will be the next step. Okay. So in the next step, I will write y by y minus 2 equal to minus 10 power 2x. This minus I will bring here to the other side. Y by minus of y minus 2 equal to 10 power 2x. Or y by 2 minus y equal to 10 power 2x. So this kind of arrangement will help us in isolating x, in getting what is x. Okay, so now what I have to do, I will take log on both the sides. Log y by 2 minus y base 10. This side also log of 10 power 2x base 10. So I gave you a formula here. Log of y by 2 minus y base 10 will be as it is. For this, the answer will be 2x. Do you remember the formula I gave you while explaining the synopsis? The formula I gave you here, I'm writing log of a power x base a is x. This is the formula. Log of a power x base a. That is x. That means we will have 2x here. This is how I have used the formula timely. For the time being, this will be helpful. Or I can write x equal to 1/2 of log of y by 2 minus y base 10. But if you want to write exactly the inverse function, again I am erasing this side because we don't have place to write the next step. You can see what I write on the last step. I did not erase that. Okay. Now I have to write the next step. So from here, I will go to next step. If you want to find F inverse, that means if you want to find Y, you will write it as 1 by 2 log of x by 2 minus x base 10. That means instead of x, I wrote y. Instead of y, I wrote x. So which option you can see this? You can see in B option what we got for inverse function. Let's go to the next question, 30. F of x is given as log of 1 plus x by 1 minus x. And g of x is given as 3x plus x cube by 1 plus 3x square. Now in this question, what do we have to find? I think there is a typing mistake here in the question. So I will correct it. Let me see the question. What is the typing mistake? I will tell you and I will correct. You have to find f of g of x. This is the question which you have to find. It is not there in the question. Now I'm adding. So what we will do is we will keep f and we will write g of x. What is g of x? 3x plus x cube by 1 plus 3x square. In the next step, in the function itself, I will substitute 3x plus x cube by 1 plus 3x square in place of f. See the f function. See the f function because we are dealing with f function. In the f function, you will substitute 3x plus x cube by 1 plus 3x square wherever x is there. So what I will do? Log of 1 plus, in place of x, I will write 3x plus x cube by 1 plus 3x square by 1 minus, again in place of x, I will write 3x plus x cube by 1 plus 3x square. Now, as I said, there are too many numerators, too many denominators. To make it as a simple fraction, multiply top and bottom by 1 plus 3x square. so that you will get an easy fraction. Okay, I will write base 10 because it is understood. Log alone means base 10. Even if you won't write base 10, that is also okay because in the question they did not give you. It is understood. Okay, how to simplify this? I will have log of, first of all, 1 I will multiply with this. 1 plus 3x square plus, when I multiply these two, 1 plus 3x square and 1 plus 3x square, both will cancel. Left of just 3x plus x cube. Same way in denominator, multiply 1 by 1 plus 3x square minus, when you multiply 3x plus x cube with 1 plus 3x square, actually 1 plus 3x square will get cancelled. And you will have minus of 3x plus x. Minus 3x minus x. This is left off. But this, if you see, the numerator is the formula for, sorry, here x cube. I did not see this x cube. It is covered by the brackets. The numerator is the formula for 1 plus x whole cube and denominator is the formula for 1 minus x whole cube. So together I can write 1 plus x by 1 minus x whole cube. Or I can bring the power 3 outside by properties of logarithm and just write 1 plus x by 1 minus x. So 3 times this log 1 plus x by 1 minus x is nothing but the original function f. So the final answer is 3 into f of x, which is there in option B. Next, we can go to question number 14. In question number 14, f is a function from 1 to infinity to 1 to infinity. F of x is defined as x plus 2 by x minus 1. Show that it is 1 function. So, for a 1 function, to prove, we will start with f of x1 equal to f of x2. And in the end, we have to get x1 equal to x2. In the end, last step should be x1 equal to x2. Then I can say f is 1 function. So I will start. F of x1 means x1 plus 2 by x1 minus 1 equal to f of x2 means x2 plus 2 by x2 minus 1. So what I did, in place of x, I am writing x1 for the left side, x2 for the right side. x1 for the left side, x2 for the right side. In place of x in the function I have written. So now cross multiply. x1 x2 minus x1 plus 2x2 minus 2 equal to x1 x2 plus 2x1 minus x2 minus 2. So you can cancel x1 x2 both the sides. You can cancel minus 2 both the sides. Then 2x2 minus x2 equal to 2x1 minus x1. Or I have x2 equal to x1. Just I shifted x1 to this side and I shifted x2 to this side. So that I will have x2 equal to x1 or that is nothing but x1 equal to x2. So in this way, I can say that it is 1, 1 function. I will not waste this page completely. I will write here, because I got x1 equal to x2, I can say f is 1, 1 function. Now, how can I say about onto function? I will take the function y equal to x plus 2 by x minus 1. So this is the function I have taken. Looking at the function, I can say the denominator should not be equal to 1. X should not be equal to 1. That is the domain of the function. X should not be 1, because if x is 1, the denominator will be 0 and the y will be undefined. So domain of the function is x not equal to 1. And from the function also we have domain of the function 1 to infinity, not equal to 1. So that means we can say for every x in the domain, there is a single y in the codomain. That means 1, infinity group. You know, this is the domain of the function, this set, and this is the codomain of the function. So that's why I have written. So for all x, there is a single y in the interval 1, infinity. That means x you are taking 1, infinity. The domain you are taking 1, infinity. Domain of f. Domain of f is 1, infinity, which is matching with the question. Similarly, you can take the equation instead of y equal to, you can take x equal to. How you can take that? Take y equal to x plus 2 by x minus 1, cross multiply, xy minus y equal to x plus 2. xy minus x equal to y plus 2. Minus came here. Is that okay? I will repeat this step if it is not okay. So first of all, I am cross multiplying. You can see I have cross multiplied. Carefully you see what I did. I did xy minus y equal to x plus 2. Then I brought xy minus x, and then I took y plus 2 here. So that I will take x common, y minus 1 equal to y plus 2, or x equal to y plus 2 by y minus 1. Now I will discuss about y. The denominator y minus 1 should not be 0. Then only x will be defined. Y should not be equal to 1. So easily y is not equal to 1 means range of the function you can see. It is 1 to infinity, not equal to 1. That means I can say the function is onto function. Why did I say it is onto function? I got the domain of the function same. I got the range of the function same. And here I said only for x is not equal to 1. You have to see. If x equal to 1, y is not defined. But for all other x, y is defined. A single y. That's why it became onto. So the function is 1, 1 and onto, both I can see. That means A option will work. 1, 1 and onto. Coming to question number 50. R is the relation which has x comma y. This is in brackets like this. X and y both belong to A and x plus y equal to 5, where A is having 1, 2, 3, 4, 5. We have to say whether this is reflexive, symmetric, transitive. That you have to see. First of all, reflexive. How will it be reflexive? Because in set A, you have 1, 2, 3, 4, 5. That means reflexive relation. If I take, how will it be? For every x, for all these, you must have x comma x, x comma x. That means 3 comma 3, 4 comma 4, 5 comma 5 in the relation. Then only it will be reflexive. But I cannot take these because 1 plus 1 is not giving 5. X plus y, when you add, you must get 5. 1 plus 1 is not 5. 2 plus 2 is not 5. 3 plus 3 is not 5. 4 plus 4 is not 5. 5 plus 5 is not 5. So clearly, the relation is not reflexive. Okay. After not reflexive, we have to see whether it is symmetric or not. So now what I will do is, I will write the relation itself. I will take 1, 2, 3, 4, 5, these elements. Which two elements, x and y, will give me 5? I will see. I can take 1 plus 4 equal to 5. Similarly, 2 plus 3 equal to 5. Anything else I can take? I can take 3 plus 2 equal to 5, and I can take 4 plus 1 equal to 5. So, looking at this relation which I made, I can say that R is symmetric. Why it is symmetric? Because if x comma y is there, y comma x is also there. If x comma y is there, y comma x is also there. That is why it is symmetric. Now we will see whether it is transitive or not. How to see whether it is transitive or not? Concentrate on these two. There is 2 comma 3, there is 3 comma 2. But 2 comma 2 is not there in the relation. Similarly, there is 3 comma 2, there is 2 comma 3, but 3 comma 3 is not there in the relation. So the transitive relation is not satisfied. It is not transitive, I can see. Even if one case doesn't satisfy, I can call it as not transitive. So what I got? Not reflexive, symmetric, not transitive. And that is option A. Next, we can go to question number 60. If f is a function, this is not finction, it is function, typing mistake, of real variable, x is satisfying f of x plus 4 minus f of x plus 2 plus f of x equal to 0. This is the equation. For any x, it will satisfy. But then you have to see f is periodic, you have to find the period. So first, as I know this equation will be satisfied for any x, I will name it as equation 1. Now my first work is I will put x as x plus 2 everywhere. Still the equation will be satisfied. So when I put x as x plus 2, I have x plus 2 plus 4. That is x plus 6 minus f of, in place of x, I will write x plus 2 plus 2. That is x plus 4 plus, in the function, in place of x, I will write x plus 2. That will be equal to 0. Everywhere x, I have put x plus 2, x plus 2. Still the equation will be satisfied. So this is equation 2. Now what I will do is I will add equation 1 and equation 2. What will happen if I add these two equations? Observe carefully. So this term will cancel and this term will cancel while adding, because one is positive, one is negative. And so I will get just f of x plus 6 plus f of x equal to 0. Name this as third equation. Now this equation will be satisfied for every x. That's why x, I will put it as x plus 6 and see what will happen. So I will have f of x plus 6 plus 6. That is x plus 12. And then plus f of x. Here also x, I have to write x plus 6 equal to 0. This is named as fourth equation. If I plug x as x plus 6, the equation will be satisfied. Okay. Now what I will do is, I will do 4 minus 3. So what will happen? F of x plus 12 plus f of x plus 6, the fourth equation, minus the third equation, minus f of x plus 6 minus f of x equal to, the right side 0 minus 0 I will have. So these two will cancel. I got f of x plus 12 minus f of x equal to 0, or f of x plus 12 is equal to f of x. When you add something and you get same as the original function, I told you in synopsis, while writing synopsis, I told you during periods of the function, how can I find the period of the function? To function, if you add x plus a inside, in a function, inside if you add a, that means x plus a, it will be same as f of x. Even if you take f of x plus a, it will be same as f of x. Then you can say this a is period of the function. So in this question, period of the function is a, that is 12. Because in the function, even if you take x plus 12, you are getting same as the function x. Then I can say it is periodic. And it is periodic, its period is 12. You can go to part C. Coming to question number 17. X is given as 8 power n. It is not 8n. It is 8 power n minus 7n minus 1. N is natural number. And y is given as another set. What is y set? 49 into n minus 1. N is again natural. So I have to say whether x is subset of y or y is subset of x or x equal to y. So what I will take? First, I will take the elements of the set X. 8 power n minus 7n minus 1. These elements belong to the set X. That means if I take n equal to 1, because I'm taking natural number, n is a natural number. What will I have? 8 minus 7 minus 1, which will be 0. Now, if I take n equal to 2, what will I get? 8 square minus 14 minus 1. And what is that? 49. Like that, you can do n equal to 3 also. But what you see is, whenever you take n greater than or equal to 2, you can take equal to 2, greater than 2. 3, 4, 5, all these you can check. What will happen is 8 power n minus 7n minus 1 will be multiple of 49. As you go, even if n cube, if you want, you can check. If n is 3, what you will have? 8 cube minus 21 minus 1. What is 8 cube? 8 into 8 is 64 into 8. 8 4 is 32, 8 6 48, 512. From 512, you will subtract 22. So when you subtract, what will you have? 490. This is also multiple of 49. 49 into 10 will be 490. So always in the set X, 8 power n minus 7n minus 1 will be multiple of 49. And in set Y also, you can see you have 49 multiplied to some number n. That means in set Y also, multiples of 49 are there. In set X, multiples of 49. In set Y, multiples of 49. Is that okay? So all the elements of set X are present in set Y, because in set X you have multiples of 49. In set Y also you have multiples of 49. So I can say X is subset of Y. Do you know why? Why I did not take Y is a subset of X? Why did I take X is subset of Y? Because in the set X, you have 49 into 1. Of course, first 0, I'm not counting. This answer 0, I'm not counting. I'm counting 49 into 1. And then next, what did we get here? 49 into 10. So like this elements are there. But in set Y, when you put n as 1, 49 into 0, n as 2, 49 into 1. I'm writing directly. N as 3, 49 into 2. N as 4, 49 into 3. So all multiples of 49 are there. In X, all multiples of 49 are not there. Only 49 into 1, 49 into 10, like that some other number. But not all. 49 into 1, 49 into 2, 49 into 3, like that all you don't have. That's why I cannot say all the elements of Y are not present in X. Y is not subset of X, but X is subset of Y. So that is why we are going to A. X is subset of Y. Let's take the next question, that is question number 18. In question number 18, the set A is given to you. You have to write power set of A. What is power set of A? You will take all possible subsets. That means if you want, you won't take anything. If you want the other possibility, you will take only 5 as a set. If you want, you can take the set 5 as a set. So I have taken nothing. I have taken one element, that is 5 in the set. I have taken one element, that is set 5 I have taken here. So if I want, I can take two elements. Two elements means all the elements I can take. I can take 5 and the set 5 together. So these are the number of elements. And that you can see here. It is empty set means 5. Then the set having 5. Then the set having 5. And this is nothing but the set A itself. That's why we can go to option C. Then question number 19 is finding the domain for cot inverse X. When I told you synopsis, I told you domain of cot inverse X is any real number from minus infinity to infinity. But that is for cot inverse X. Here we don't have X, we have this entire thing. So we have to take care about this because that is a fraction. What I can say is this is a fraction with square root in the denominator. Remember, there is denominator and there is square root also. Both are there. So I have to take care of both. First of all, under the square root, whatever is there, that has to be greater than 0, but not 0. Like x square cannot be equal to greatest integer function of x square. So this is the thing you have to notice. So first condition, if you see, x square squaring means you will get positive only. And here also we are taking x square. X square will be positive only. This x square is positive and this term is also positive. So of course positive minus positive, will you get positive or not? Positive minus positive, will you get positive? You will get positive only if this number is larger, only if this is larger. That means x square has to be greater than greatest integer function of x square. That is one condition. Is that clear? And coming to the next condition, x square cannot be greatest integer function of x square. And you know, the answer for this greatest integer will be integer. Some integer, let that integer be n. So that means x square cannot be n, or x cannot be plus or minus square root of n. So this is enough for us to decide what is happening. So you can go for option C. X can be any real number, but x cannot, we are subtracting, we are removing. X cannot be equal to plus or minus square root of n. This will give me the hint to select which option is correct. I think we have done many questions. With this, you will get idea about how to do the problems in the chapter sets, relations, and functions. Question number 20, if you see, the domain of the function f of x equal to 1 by 3 minus log of x minus 3 base 3 we have to find. Because we have denominator, because we have log, we have two conditions. First of all, the denominator 3 minus log of x minus 3 base 3 should not be 0. If it is 0, the function will become undefined. The second condition is because there is log, x minus 3 has to be greater than 0. These two conditions you have to take. The first condition, 3 should not be equal to log of x minus 3 base 3. Or how can I write? 3 power 3 should not be equal to x minus 3, because log I am changing to exponents. This 3 will be the base and this 3 will be the power. 3 power 3. 27 should not be equal to x minus 3. 27 plus 3 should not be equal to x. X should not be equal to 30. That is one condition. The other condition, x has to be greater than 3. So on the number line, if you take 3 and 30, x is greater than 3, not equal to. Greater than 3 means it will go up to infinity. But x should not be 30. So how will you break the interval? You will take 3 to 30. You will not take 30. And then you will take 30 to infinity. That means you will not take 30. That is very clear. So this will be the domain of the function, which you can take as option C. So in this way, we have completed multiple choice questions of this chapter, sets, relations, and functions. So you have to practice more problems. You have to go through the synopsis. Then only you will get good scores from this chapter. With this, we will end this session, and in the next class, we will go to the next chapter, that is complex numbers. Before coming to the class, you be perfect with this chapter. Open your intermediate textbooks and read this chapter, learn this chapter and come, so that you will understand whatever I am saying. See you again in the next class.